Rose. We are fascinated by your travel, your journey. It's so fabulous. What did you do in the classroom to work on this conference? We have watched your videos at least 5 times because it's so fascinating. And today we have a couple of questions. And the first one is, is it pretty in space? Can you describe what you see? So, first question, the Canadian speaking, Canada arm speaking, yes, but speaking in coding. So we can make it move by sending coded messages, programs. This is the case for every machine around us, and that's why learning coding is so important and learning programming. Then, regarding what we see outside, yes, it's very beautiful. And what's so beautiful is the Earth. Outside, it's dark. The sky is dark. There are stars, but it's dark. But when we look at the Earth, this is fantastic. We see the roundness, and it looks like it's glowing. There is a blue layer glowing permanently around the Earth, and every time I find this very impressive. And we see the lightning and the clouds moving. We see the moon, which is very nice, but it's not moving. The Earth is permanently in movement, and the glowing of the Earth is fascinating and beautiful.
Thank you, David. I'm still wrapping my head around the fact that we're talking to you from space. But I want to move on to our next question from our friends over at Seeker. They want to know, what's the most difficult thing to describe about space?
So, when I had so many years of training coming to space, training to ride the rocket, training to be here on space station, that a lot of it is familiar initially because you've seen it a little bit, you've seen films, maybe videos, trainers, mock-up facilities, but at the same time, there's something so bizarre because you're floating. You're just floating all the time. And it can be, I mean, now I'm used to it, and I can be standing like this talking to you, and it doesn't bother me at all. I don't feel like I'm upside down. I only notice when I look around, but I can be like this. I can sleep in any position. It doesn't really matter. And it's so strange how your body adapts. The human body and the human mind is so adaptable that after a while, I feel like I was born here almost. I can fly very easily, and I don't get confused. So that's, I guess, the most amazing thing here is the fact that you can actually adapt to this environment, and it feels, at some point, normal.
Merci David.
Thank you, David. This is a question from this Bastien. My question is, in space, what is your next dream? What do we dream of once we've been to space? Yes, and what do we dream of? I proceed with one dream at a time. Of course, I dream of being back to Earth with my family, my friends, the people I love. We are in contact, but it's more abstract. To see the Earth so beautiful, so unique, it reinforces in me the conviction that human beings are one single group. Of course, there are differences, but that's what unites us, and it gives me the desire to contribute back down on Earth, to contribute to the unity of the people.
Thank you. Next, we have a question from ASAP Science. They want to know if the space station would have some kind of solarium. Is your risk of sunburn more significant from space?
So definitely the rays of the sun here are very, very dangerous for human skin with the ultraviolet. But all our windows have very, very strong ultraviolet protection, just like sunglasses have on Earth. There's a few windows that do not have that we use for scientific purposes, for experiments, and we would not open those window shutters without, wearing sunscreen and sunshade protection. But when you open the window shades, you can feel the warmth coming in, but our skin is safe because of the ultraviolet filters that are embedded inside the windows. So we actually have kind of a solarium. It's called the cupola. It's like a hemisphere. It's like a hexagon of glass panes, and we can fit our entire body in there, and you feel like you're floating in space. It's my favorite place on station.
Here is a question from Kip Boutin. I'm very intrigued by the fact that there are many years of work and preparation. And they are very precise events and that are fairly short. But it seems that you prepare for months. So what's the type of preparation you're getting? First of all, congratulations for your great success. I'm sure that what we have in common is the preparation and visualization for us astronauts. We try to imagine what it's going to be like. We put ourselves in a situation and we imagine what it's going to be like to be in the spacesuit and how it's going to happen, to prepare our mind for the stress that is going to happen. And we visualize, and when we visualize, we get prepared. And what is very important for us, and you, I'm sure, athletes, we think about all the problems that could happen. And we try to analyze and think of everything that could go wrong and prepare ahead of time, because that takes away the anxiety. And if one day we have an issue, then we know what to do because we are prepared. We talk to people who've been here before us, like a coach, and they give us advice and tips, and that's what's very good.
I'm looking forward to hearing your answer to this next question, which comes from Sean Smith, head coach at Social Media Camps. Now, Chris Hadfield demonstrated the power of social media in sharing his experience on the International Space Station. Now that it's your turn, what message do you hope to emphasize to that same global audience?
So, we all come to this from a personal perspective, I suppose. For me, what is really most important about human space flight and what's personally transformative is the perspective that it gives me. I think human beings we're explorers, and we always like to try to step back and get a bigger and bigger understanding of the world around us. We started out metaphorically in the caves, got out in the plains, climbed mountains, went in the other valley, crossed rivers, reached the ocean, built boats. Every time our bubble got bigger, if you want, in our minds, and then invented airplanes, flew around the world. Now we're getting out of the Earth and seeing the Earth as a whole from far away. And that perspective gave us so much wisdom. That perspective of the whole world as one is what gave rise to the environmental movement, what gave rise to globalization and bigger ambitions for world peace, and what gives rise for collaboration around the world. And I think these are very important for the younger generation. So to me, we owe to space that great perspective it gives us into where we actually come from. That image of the Earth floating in space, that's our spacecraft. Every human is an astronaut. We're all in the same spacecraft Earth, floating in the vacuum of space. And we've got to take really good care of that spacecraft, and we've got to work together because there's nowhere else that we can live.
David, la prochaine question vient d'Alexandre Champagne, photographe.
Alexandre Champagne, photographer, asking about taking pictures of Earth from space. So we learn from astronaut to astronaut, but first of all, the Earth is moving. So your subject is always moving, but maybe it's going to come back in a couple of days, maybe there will be new clouds. And then you have contrast, light contrast. The Earth can be very shiny with the sun, and then you have the blackness, and you have to manage the different level of light and the movement of the Earth. So it's and the fact that the beautiful subjects are very elusive and are here for only a moment.
We have another question from Seeker for you. During your 6-month stay, the crew will take part in roughly 250 scientific experiments. Which one are you most excited for, and why?
So on space station, as you know, we do hundreds of experiments, and we've done thousands since the beginning of station. They're on very different subjects, ranging from fundamental physics to plasma, to astronomy, material science, technology demonstration, life support technology. For me, because I was a physician before, working in a small village in the Arctic, what's most exciting is everything that has to do with remote care, healthcare. So, to take care of the health of astronauts that are far away from Earth is a very similar problem to taking care of the health of people who live in a small community in a remote place, like in northern Canada, for example, or any small village, or take care of people who are soldiers who are deployed, or expeditions climbing mountains, or people that work in dangerous environments on the Earth, or even elderly people who have a hard time leaving their home to go to the hospital. They're kind of themselves in a remote environment. And so all the technology that we developed to do what we call remote care medicine or telemedicine, we can apply directly to people on Earth. So that I always find that particularly exciting whenever we come up with some good ideas to make astronauts more independent in taking care of their own health care, because I know by experience that will have direct applications on Earth.
Yep.
Merci. Au tour maintenant de Martin Carly.
Martin Carly is our next guest. Hello, David. So, I have a question, but also an answer, if you will. So, why do astronauts have to train like if they were on board the ISS? Is it because of bone mass loss or gain? So the answer is that if we don't do anything, we're going to lose bone mass, because our body conserves its energy, and we have strong bones because we need it. Things are heavy, we walk, so the body feels the impacts, and if we stop moving because we're sick, or because we're idle, or because we're lazy, then our body says, I don't need my bones, and gets rid of them. So here, very quickly, we see a lot of calcium in our urine.
In the air, but I use the gravity to make sure I land on my feet. But once you're at, zero gravity, you're in space, how is your spatial orientation impacted?
That's a very good question. Initially when you come to zero gravity, you're very easily disoriented because your brain is missing the information of where is up and where is down. You still have the feeling that you're turning, but you kind of lost all absolute reference of what's up and what's down. So initially, it can actually make you a bit nauseated, like being car sick. And then after a while, it's as if your brain decided to forget about gravity. That's not there anymore. Too bad. And all you have left is visual cues. So if you notice, looking around here, we made walls. We decided to have walls that were vertical, and a floor and a seating. And this is all abstract. everything that's written on the wall is written the same way, up and the writing up, so that mentally we know looking around which is up, which is down. But other than that, there is no way to tell. If I close my eyes and I slowly tumble, when I open my eyes, I'll be surprised which way I'm pointing because I don't have that gravity reference coming from the inner ear. It's been disconnected, if you want. And when I come back to Earth and gravity hits again, I'll have to relearn to use the sense of gravity to hold, because I won't be able to use that sense to stand up, and I will be very easily tipped over. I have to hold someone's hand or hold someone's shoulder to walk for the first few days. So yeah, we kind of adapt to it in a way. No gravity, too bad, forget about it. Let's use other things. It's mostly what we see.
So, unfortunately, that's all the time we have with you. We want to thank you so much for the time you gave us. And we wish you the best for all the EVA, and we want to applaud you and the all team at the CSA is wishing you the best. Thank you.
Merci beaucoup. Excellente question. Belle discussion.
Thank you so much. Very good question. Great discussion. It's always good to have a break like this and be able to share my experience. So thank you for preparing this event. Thank you.
Station, this is Houston ACR. That concludes the event.
Thank you, Canadian Space Agency and participants. Station, we are now resuming operational audio communications.